All right, round two, fight. So I already tried this a bunch. I should have tested before I tried recording previously, but it's demo time for some new tooling. I started at noon today. It's now 7:30. That includes a couple breaks. Anyway, um, I am looking for a simpler way to distribute source code that my projects are dependent on. One of the things I've got going on right now is this new high performance networking library for large data acquisition and control systems. And so I've got this Vecto project that I've been working on for a bit now, and I've got a vendor that I'm working with that is it's his software stack that we're using at the company I'm at now, and we need to replace the communications in it to get more performance out of it. So I've written this. He was here all last week, but that is getting off into the weeds and probably not interesting. What is relevant is this Vecto project depends on about two-thirds to three-quarters of the folders up here. Um, now, what I'd like to do is they can just pull down Vecto and then have some tooling that gets everything else that's needed. Kind of like with VIPM, how VI packages can list dependencies and VIPM will make sure they're all installed and available. Kind of going for the same thing here. Now, some of you might be thinking, well, you're using Git. Why don't you just use Git submodules? This sounds like Git submodules with more steps. You're not completely wrong. This will, in fact, enable submodule workflows. But the problem is, this is LabVIEW. So, in order to keep all of the relative dependencies consistent across everything, you can't nest submodules. So, if Vecto were to have a subfolder in here, maybe I name it lib or libs or submodules or whatever, and then put the things that it depends on in there, well, guess what? Some of these other things are expecting other dependencies that are peers of themselves or have dependencies. For instance, HTTP server, if I followed that same model, would have a libs folder in here and it would have utilities, some JSON stuff, all of my stream parsing stuff. And then when Vecto needed it, Vecto would have HTTP server in its libs folder, but HTTP server would, and now if I want to use HTTP server in another project with a different layout, all of the relative pathing just kind of falls apart pretty quickly. So the right answer when using submodules with LabVIEW is just to make all of your repositories peers of each other. And you can't have a submodule point at another submodule that's a peer. So this is the gap that fills. Um, and when you get a large application that's based on a whole bunch of submodules, I might want to make an update to one of those submodules and in a continuous integration pipeline, pull down that repo. But if it's the repo by itself and it has dependencies on other repos, I kind of can't test anything. So with that repo, I want to be able to get all of the other peers that it depends on, and use that for distribution, use that for setting up a new environment, and use that for pipeline environments. So I've got a little bit of command line tooling that I've started here. We can't do the most recent one. We can see here that I'm in this Vecto folder. So I'm in this working folder, and we're going to init, and I'm going to name it Vecto. So now I've got this GPack file here, and it by default turned on all of the dependencies. Well, I guess we're jumping ahead a little bit. Um, well, it shouldn't have filled out this dependency section, but in that amount of time, what it did was get the Git information for this. So Git is what I'm supporting right now. This could be extended to do Subversion, just file access, maybe downloading things from HTTP web servers. Um, Kind of anything that can follow this kind of um, information scheme for identifying where to get code. But what this has done, and again, jumping ahead a little bit, As we can see here for version, I'm just using the git commit hash. Also keeping track of branch because usually when you download things as submodules, they start in a detached head state. So I hope to make this tooling a little bit better about getting reattached to a branch and then checking out a specific commit on that branch. That could still get a little funky if you accidentally change and commit to that repository. Um, you'll probably have to do a merge, but also keep track of where it lives relative to the folder that I'm working in. Um, but now I could write, which I haven't finished this part yet, is something that reads this file, which reading the file is done, but then clones down all of these for me and puts them in the correct checkout folders. So even if I've checked out folders that aren't the same name as the repository name, which would be a bad idea. Again, we want to make it as easy as possible for peer dependencies to find each other and have the LabVIEW links stay intact. But just in case you do have a different naming convention scheme, it does keep track of the folder. Um, but I could get the idea is that I would run GP install and it would then make sure all of this is checked out and at these specific versions. So without having to do anything special in these other repositories, this would work for the Vecto repository. And then as I add more features and as these other repositories get their own GPack files, that would make it possible to build some additional layering on top um, and do recursive dependencies. So if, for instance, at a top level, so because what I'm not doing is I'm not going into these other projects and seeing if there's anything else that they depend on. Um, this is this does pull everything that the Vecto project lists in under its my computer target, well, any target in the project, as well as anything listed in the dependencies, and it checks to see if there's something that can be tracked with this tool. So basically, if it's a Git repository or a Git submodule, um, and it is part of this project, it will show up in there. And of course, it decimates it down to just the unique paths for everything. But this should be a far simpler way to distribute source code and be able to do it quickly and easily, kind of segregated to each project. Or if you've got a handful of projects that you keep side by side, you could make sure all their dependencies are alongside them. The pattern I'm going to generally be using is there is going to be a repository serving as a super project that would then have a bunch of submodules. The super project would have the LabVIEW project that has the build specs I'm interested in, and then every other bit of source code would be in submodules, and those submodules would be managed with this tooling.